Hi everyone, my name is Federico and I'm a PhD student at University of Padova, Italy. And today I want to convince you that we need to improve the reliability of future telecommunication systems. Why do we need this? Well, in the last years, telecommunication systems start to support an increasing number of different applications. Just think about your mobile phone that now can be used to watch movies thanks to video streaming application or to monitor your physiological data thanks to healthcare services. All of this cannot be done until a few years ago. In the future, telecommunication systems will support even more specific user classes like public safety operators. We can consider, for instance, a group of firemen that need to react to a fire and use a drone to monitor the fire area. Therefore, the firemen need to communicate with the drone and process the images that the drone transmits. Unfortunately, traditional networks are not up to support such a heterogeneous environment. Indeed, traditional networks are characterized by a static allocation of system resources, are not able to provide service differentiation, and finally, if some part of the network gets damaged because some events, the entire network functionalities can be compromised. If we consider a public safety scenario, all these challenges get even more critical. Indeed, in a public safety scenario, we need to support specific class of users like firemen, police operators, and healthcare professionals, which requires application with highly dynamic requirement that change very fast on time. And moreover, the network infrastructure, it is more likely to be damaged because events like natural disaster or other emergency. In my research, I'm investigating a new solution to face the complexity of this critical environment. In particular, my solution is based on two powerful paradigms. The first is network slicing, which makes it possible to define multiple logical networks over the same infrastructure, so that each of the network can be associated to a specific class of users, increasing service differentiation and the optimization of the system resources. The second tool that I'm using is artificial intelligence, which makes it possible to define more specific resource allocation strategies that can be adapted to different scenarios. In particular, my solution is based on a distributed architecture, where each element of the network is associated with an artificial intelligence unit called agent. If we consider an agent placed in a link, such an agent will have the task to orchestrate the bandwidth available in the link. And in particular, all the agents are trained according to a reinforcement learning approach. So an agent in a link will first observe the status of the link where it is implemented. Then we'll choose an action, so it will assign to a specific communication flow a certain amount of bandwidth, and finally we'll get a reward. And such a reward will depend on the performance of all the flows that cross the same link. This framework forces all the agents to collaborate towards a common goal, which is the maximization of the system utility. In particular, my solution is very flexible since it can be implemented in different network topologies without the need of an additional training phase. It is reactive because each of the agents react autonomously to change in the network status, and finally, does not require any human intervention to operate. In particular, in a public safety scenario, if some part of the network infrastructure get damaged and stop working, my solution makes it possible to define a new slice to support public safety operators and increasing their ability to fight the critical events that they are called to face. This ends my presentation, and if you are interested in this topic and you want to further discuss with me about this, please send me an email. Thank you.